One of the interesting things about Einstein's equations is that none of them suggest time goes in only one direction. They work equally well if time goes forwards or backwards. This is in contrast to everyday experience.
One of the conundrums is that the laws of physics, for the most part, do not distinguish between time going forward and time going backwards. And yet, the actual world that we experience certainly is different forward to backwards.
One scientist who puzzled over the directionality of time was Arthur Eddington, a 20th century astronomer who defined the concept of the arrow of time, based on observations made by the 19th century physicist Ludwig Boltzmann.
In space, there's no preferred direction. There's no difference in the laws of physics if you look left or look right. But there seems to be an enormous difference between the past and the future. That's what we call the arrow of time. And it's a little bit mysterious. Why is the past so different from the future? We think it's not a difference in the deep down fundamental laws of physics. It's actually just a difference because of the universe in which we live.
The arrow of time is just time as we experience it. 1 second following one other second following another second. It's just the psychological experience of time. And the fact that things change as we experience them, but as seem to happen in the world, forward. So buildings get built, but they decay slowly, and it's that decay that is at least partially responsible for the arrow of time. It's the increase of entropy. So in thermodynamics, we know that things get more random over time. And that appears to be very fundamental to our experience of time and to what's happening in the universe.
The arrow of time is based on the second law of thermodynamics, which says that disorder, known as entropy, increases with time. For example, a building left untouched will slowly decay into its surroundings. It will disintegrate into a more chaotic state, but it is highly unlikely that the building will become more orderly over time. This is because there are many more ways for a system to be disorderly than orderly. There can be many ways for something to break, for instance, but only one way for it to be put back together again. A system will be less disordered in the past and more disordered in the future. This is the arrow of time.